So this presentation is about the strain gauge sensor and overview. This transducer is used in industry, in process control and instrumentation, in general measurement. And it is very commonly used for measurement of a force, for measurement of a pressure, for measurement of some other parameters such as the load. So sometimes it is also termed as a load cell in industry. So it is basically based on the principle of the strain. So what is strain? Strain is an amount of deformation due to an applied force, and more specifically, strain is defined as a fractional change in length. You already know, whenever you are applying a force or a pressure over certain material, its length is changed. Now, it depends upon the materials to materials as well as the force, how much length is changed, and generally it is very smaller one. So the strain can be a negative or it can be a positive if it is a tensile or if it is a compressive. And in practice, the magnitude of strain is very small. Therefore, it is expected as a micro strain. So while designing a sensor transducer, which is based on a strain change principle, so it is a micro strain. And in the bottom side, you can see a element having length L with diameter D. And if you are applying a force on both the sides of the material, the length is changing from L to delta L. The strain will be equal to the difference, that is the delta L over L. So it can be used for mathematical calculations. So the strain gauge means an instrument which you are measuring, which you are using to measure the strain, but the strain is not directly measuring. Actually, you are measuring certain other parameter, certain other, the physical parameter, maybe the load. Strain gauge is a device used to measure the strain on an object. It is termed as a load cell. Now, this strain can be in the form of a load falling over any object. The strain may be in the form of a pressure. The strain may be in the form of a torque, which you are measuring by using a strain gauge. It was invented in around 1938, and the most commonly type of strain gauge consists of an insulating flexible backing which sports a metallic foil pattern. So this pattern is generally pasted over the substrate, over the base where you are going to measure the strain. In this example, so this is the strain gauges can be constructed by the different ways. It may be a simple wire which is wrapped over certain special mechanism, and it may be a foil, it may be a semiconductor type of a strain gauge, which we will consider later on. So consider this is a for a foil type of a strain gauge, just for the understanding how the phenomena is taking place. So it may be consisting of a matrix which is made up of a specialized wire whose resistance is changing in a large amount when there is a small change in the length of the conductor. So this conductor is actually a foil type conductor which can be pasted over the base where you are going to measure the force or a strain. So assume the length of the base, length of the matrix, which is in the form of the foil, is length L, and when you are giving the tension to the material, the length is extending. So in that case, the resistance R is changing. Similarly, if you are compressing the material uh, by changing the deformation of the material over which you have pasted over this foil, so the length is reducing down. In that case, again, the resistance R is changing. So we are well aware about the relationship of resistance R is equal to rho L upon A for all materials or metals. So here the R is the resistance, rho is the property of material, that is known as the resistivity of the material, which depends upon the materials to material. L is the length of the wire, and A is the effective cross-sectional area of the wire. If the the any of the parameter, like if the rho is changing, if the L is changing, if the A is changing, the resistance R is changing. In the case of the strain gauge, the L of the wire is changing. However, the A may also be changing with the change in L, but we are concerned with change in the L. So it has also the overall relation is also affected by the A, which is the area of cross section of the wire. So there are various applications, industrial applications are there in process industry, in measurement, in any of the control system. We are using a strain gauge for the measurement of a pressure. It can be used for measurement of a force. It can be used for measurement of a small displacement. It can be used for measurement of a torque, and it can be used for measurement of a load. In all the cases, you can see the example. In the first example, you are measuring the load. In that case, you are pasting three different, the strain gauges on the part of the link where the maximum, the uh, bending moment is there. So as the material is having certain bending moment, the molecular alignment of the base part is changing, and ultimately the length of the foil is changing. So consequently, the resistance R is changing, which can be measured in the term of the the torque. Similarly, the load can be measured from in the cantilever from the bottom side as well as from the upper side also. So you need to paste the strain gauge on the cantilever where the maximum deformation is supposed to be there. So as the cantilever is deforming, it is changing the length, and ultimately the resistance is changing. Similarly, it can be used for measurement of a pressure if you are mounting a strain gauge on a diaphragm of any of that is the system. So as the pressure is changing, the diaphragm deformation is taking place, and consequently the length of the foil as well as the wire which you are pasted over as a strain gauge sensor will change. It is used for the measurement of the cracks in the walls also, and it has large number of the other applications are there. So these are the only few application where the strain gauge can be used. So the basic principle is that if a metal conductor is stretched or a compressed, its resistance change on account of the fact that both the length and diameter of the conductor is changing. So consider that this one is a metal conductor having a particular length L and having the diameter D, and you are applying a tensile force F over it, and in that case the length L is changing from L to the delta L, and the diameter is also reducing down to the delta D. So expression of if we are measuring the length, measuring the resistance of this wire, so R is equal to rho L upon A, the resistance of the unstrained conductor. And now when we have applied a stress or a strain over a wire, so assume that let's the tensile stress S is applied of a wire. With the result, there is a change in delta L, change in delta A, and change in the delta D is the diameter. So in that case, the resistance R is changing from R to delta R. So by differentiating with respect to the stress, we can find out this equation number 2, that is the dr over ds is equal to the partial derivative of L and with respect to the strain. Similarly, the partial derivative of A with respect to strain and resistivity. So by simplifying the mathematical equation throughout with the equation number 1, and in this case we are getting in equation number 3, per unit change in resistance is due to the per unit change in the length, and we come to know that the per unit change in resistance is also due to the unit change in the area and also unit change in the resistivity of the material. So in that case, the these are the parameter which we are finding out if we are considering the value of A is equal to pi by 4 d square. So we putting this value and dividing both side by A. So this equation is reduced to be this one. Now we know that the Poisson's ratio now is equal to the lateral strain over the longitudinal strain. So we are further putting this equation 7 into the base equation number 6 and finding out for the small variation, the above variations equations can be written as this equation where the GF is defined as a gauge factor. So ultimately, gauge factor is the factor which is defining about the sensitivity of any particular strain gauge, such as the gauge factor of the semiconductor of strain gauge is very high. Gauge factor is defined as a ratio of per unit change in resistance to the per unit change in the length. This is the required parameter. So we requiring a high gauge factor so that if there is a small change in the length of the conductor, if there is a small force we are applying, and there should be a large change in the resistance so that the measurement should be easy and the errors in the measurement should be less. So ultimately the gauge factor is equal to 1 plus 2 nu into delta rho over silence. So which is where the since the this delta rho over rho divided by the strain is very smaller one, since the material is same and the resistivity is the same, so gauge factor will be equal to 1 plus 2 into nu, as the strain is in the term of the micro strain. So the different, the gauge factors are there with the different materials. We cannot construct the strain gauge for with the all the material. For example, you can make the strain gauge by using iron wire, but the gauge factor of the iron is very low, and you will not be measuring a much effect of a strain over the change in the length of a iron wire. But on the other case, there are few material whose gauge factor is a large, and such as a nickel, manganese, nichrome, constantin, soft iron, platinum, carbon. So such type of the materials are used for the manufacturing of the strain gauge. Similarly, the semiconductor material is also used for the manufacturing of a strain gauge, whose gauge factor is more than plus minus 100. So there are the different types of the strain gauges are there, such as the unbounded type of the strain gauge. It may be the bounded wire strain gauge. It may be bounded metal foil strain gauge. It may be a vacuum deposit strain gauge. It may be a semiconductor strain gauge or a diffused metal strain gauge. So now it depends upon the application to application where you are going to use this strain gauge, and it also depends upon the mounting technique. It also depends upon the environmental conditions while selecting a type of a strain gauge. The strain gauge, sometimes the special deposition may be required in certain medical instruments. So in that case, it may be the diffused metal strain gauge may be required as compared to the wire wound type of a strain gauge. So let's see the construction of the unbounded type of a strain gauge. The unbounded type of strain gauge is a very simple, and in that case the wire is generally wrapped over the wrapped over the the mounting rings. So the mounting ring is connected with the sports. Okay, so these sports are wrapped with the wire, and the mounting rings is further connected with the fire post, and fire post is connected with the diaphragm. So in this case, if you are placing any force or a pressure over a diaphragm, so the links which are considered as fire post, they are coming either close or extend. So ultimately the length of the wire is changing, and with the change in the wire length, the resistance R is changing. So in many of the unbounded type of strain gauge, the wire diameter is approximately 0.03 millimeter, is very smaller. So the length wire can be of 25 millimeter, but it depends upon the manufacturer to manufacturer. The resistance of each wire, it can be vary from 120 to 1000 ohms, and the input voltage for the excitation you are applying 5 to 10 volts. So since it is a passive transducer, you are exciting this element with certain voltage, and you may be using electrical bridge for the measurement of the strain, which is in the form of a force or a pressure over the diaphragm in the unbounded type of a strain gauge. Many limitations are there with the unbounded type of a strain gauge are there, since it is a simple wire and the construction is difficult, and right now it is rarely used because of many limitations, since the wire mounting technique is very simple and chances of errors of loosening of the wires are there. So right now with the advanced technology, with the the advanced sensor technology, so the construction is a very the smaller in size and sometime fitted into the small base. So then another category is the bounded wire strain gauge. So in this case, the instead of the open wire, the wire is placed in on a base which is made up of a paper, which is made up of any suitable insulating material. So the wire is placed over the base in the matrix form. The function of this matrix or a grid is only to increase the surface, that is increase the length which you are pasting over a particular per unit area. So the fine wire with diameter again of smaller size 0.025 millimeter is used. This is just an approximate diameter. It depends upon manufacturer to manufacturer. The grid of a wire is cemented to the base, which is also termed as a carrier, and it may be a sheet of a paper, it may be a sheet of a bakelite, it may be a Teflon. you can directly mounting the wire over the base where you are measuring the strain. So it is a smaller in a size of a 3 into 3 millimeter, or maybe this is just an approximate area. It may be a larger as 25 into 12.5 millimeter length. Now it depends upon the how you are measuring. So this image is the courtesy from the Chipkin Automation System Limited. So in this case, the different, the material used for the wire strain gauge is again the sometime the composition of the two different material. In the case of a dichrome, it is nickel and chromium. Similarly, the Constantan isoelastic nickel and platinum is used. You can observe that the gauge factor of all the material is different. So while selecting a material, you need to consider the gauge factor, you need to consider the availability of the material, you need to consider the application to application where you are going to use the strain gauge. So the wire type of a strain gauge is again having many limitations, since the wire is taking the size of the this wire type of strain gauge is larger one. Construction is difficult, and the wires can also be, the loosen, and the life of this type of wire type of strain gauge may be low as compared to the foil type of strain gauge. So if you want to make the mass production of the strain gauge, the foil type of strain gauge is very suitable. It has a great heat dissipating capacity also, and formed uh, uh, from the sheet of a metal with less than 0.005 millimeter thick by photo etching process. So photo etching process is a part of the thin film technology, where the on the base large number of such the foils type strain gauge can be prepared in a single go. It can be applied in a curved surface also due to its flexibility. So it can apply it, with 10 million of cycles can be applied, and since it has a long life, and the fast response is there with the foil type of a strain gauze. That's why the modern industry is using the foil type strain gauze. Its cost is also low as compared to the wire, because the production of the production is not much expensive in the case of the foil type strain gauze as compared to the other type of strain gauze such as wire or unbounded type. Another category of the strain gauze is a vacuum deposit strain gauze, is many time used in the medical instruments also. So with the thin film vacuum deposition process to bond a strain gauze directly to the stainless steel. So the process begins with the preparing the surface with removal of all surface pinholes and the cracks, and cleaning of the surface. The next step is to deposit of an oxide layer to insulate the circuit from the metal substrate. If you are skipping this step 3, there will be a short circuiting when you are applying a voltage to the wire to the material. So in that case, the some insulation is required. Following this, the thin film resistance alloy is spotted over the oxide layer, and the film is the laser trimmed under the power to produce the 4 resistor to the Wheatstone bridges. So the now it depends upon the art of an engineer how many bridge circuit, how many resistance is pasted over the surface, and it depends upon the application at which position they are making the deposition of the strain gauze. So it depends upon the application to application. The same technology, the vacuum deposit strain gauze, can also be applied over the diaphragm, which is used for the measurement of a pressure in industry. And another form of the strain gauze is a semiconductor strain gauze, is a very sensitive. So the semiconductor wafer or a filament is a length varying from 2 millimeter to 10 millimeter, and the thickness of 0.0 mm, 0.5 mm, are bounded on a suitable insulating substrate such as a Teflon. So the gold leads are usually employed for making the electrical contacts, and the electrodes are formed by the vapor deposition. So the assembly is placed in the protective box, and ultimately you are placing the semiconductor strain gauze or on a base where you are measuring the force, pressure, or a strain. So the semiconductor strain gauze is having many advantages as compared to the ordinary type of the strain gauze. The gauge factor of a semiconductor strain gauze is very high. It is about plus minus 130, and the semiconductor strain gauze exhibit very low hysteresis as compared to the 0.05. Since the strain gauge is a mechanical type of the base, the primary detecting sensor, so in that case, the hysteresis is always there. So if you are removing the strain, due to the hysteresis, it is not taking its original position immediately. They are useful in measurement of very small strain, that is zero point zero 0.01 micron strain can be measured by the semiconductor strain gauge. The semiconductor strain gauge is much higher output, but it is stable as it is as stable as the metallic strain gauge. So it has a large fatigue life, that is 10 into 10 raised to power 6 operations can be performed. It possesses a high frequency response and can be manufactured in a very large size with the length ranging from zero point 0.7 to 7 millimeter. So frequency response is very high, means very high. The vibrations can be also be measured, or it says the response is a good. Another is the diffused semiconductor strain gauge. So this is the new technology where the thin film element molecularly bonded with no adhesive into the ceramic layer, which is deposited directly into the force detectors. So in that case, the force detector is the base part, which is under stress when you are measuring. So the adhesive bound metallic foil element is pasted over the surface, and the semiconductor wafer, which is made up of a resistor element, is diffused into the substrate and bonded to the surface with the adhesive layer. So with thin adhesive layer, so the thin film element, that is just for example the molecularity bonded with no adhesive into the ceramics layer can be deposited directly into the force detector, and this is type of a diffuse type of a semiconductor strain gauge. There is a very small difference between the semiconductor strain gauge ordinary wafer as well as the diffused, but the difference is that sometimes you diffuse the material into the base. On the base you will make a pattern and diffuse the material with some insulate, with some the adhesive material. So as per the literature, sometimes the adhesive is also not required if the base material is suitable to support the upper material which you are pasting. Whenever you are connecting the strain gauge with the electrical circuit, so since it is a passive, so it is not a self-generating sensor, you need to excite this gauge by external source. So in that case, you can connect the strain gauge in one of the arm of a Wheatstone bridge. Here the R2 is a set of the value which is equal to the strain resistance with no force is applied. When there is a no force applied, all the resistances are balanced, and the ratio of the balanced Wheatstone bridge will give you the null output and zero output. As the force is applied any of the arm, the resistance will change and the deflection will be there, that can be calibrated according to the strain. This is termed as a quarter bridge circuit. Sometimes the wires are, if the generally in practical sense the foil is much away from the electrical circuit. So if the wire is supposed to be very long, which is coming from the foil to the electrical circuit, so the wire resistance, which is here in the term as R wire 1, R wire 2, is being in a surface with which is known as a R gauge. Resistance of a gauge is also contributing to the resistance. So that means the resistance of a wire is also considering a resistance whenever you are using the electrical circuit. So since if you are using a long wire, it has its own resistance. If you are using a 5 meter 2 meter long wire, its resistance will automatically added to the arm of a bridge. In that case, you need to consider what is the resistance of a wire, and you have to include the resistance of a wire while balancing the electrical bridge. So in that case, the value of R1, R2, R3 will also be equal to the combination of resistance of a wire on a gauge size side. So this is a three-wire configuration, sometime used in the industry. So because the third wire carries practically no current, and due to the voltmeters extremely highly internal resistance, its resistance will not drop any substantial amount of the voltage. The resistance of a top wire in this diagram, which is R wire 1, has been bypassed now. that the voltmeter connected directly to the top terminal of the strain gauge, and in this case, it is leaving only the lower wires resistance to contribute and stay the resistance in series with the gauge. So there is a way, however, to reduce the wire resistance error for beyond just the method described. So it also helped to mitigate another kind of the measurement error due to the temperature. So what is happening here, since sometime, as you know, that the all the metals are affected by the high temperature. As the temperature is increasing and decreasing, the resistance of the material is also changing. So if the wire is supposed to be very long, so in that case, the temperature is also, the will affect the characteristics, as well as you will not be able to measure the correct. So in that case, there is a provision of a dummy strain gauge. So the dummy strain gauge is used to nullify the effect of the temperature change. If you are using a strain gauge under stress, under at certain conditions, so you can use a dummy strain gauge as an element of a Wheatstone bridge, and that element is connected there. And so the position of a strain gauge is will be close to the unstretched dummy strain gauge. So it will nullify the effect of the temperature by using a dummy strain gauge in place of R2. The change in resistance is in the same proportional when temperature changes, thus cancelling the effect of the temperature change. So that's why the dummy strain gauge play an important role to nullify the effect of change in the temperature in the strain gauge. So the strain gauge can be connected in the different forms, such as the half electrical bridge can be excited with the strain gauge. So in this case, the in a half bridge, the upper strain gauge position is so that it is exposed to the opposite force. As the lower gauge is compressed, the upper gauge will be stretched, and vice versa. So in this case, the electrical bridge is having the two different arms, R1 and R2. So R1 is connected to the strain gauge, which is placed over the upper side of the cantilever, and R2 is connected to the lower side of the cantilever. As you are applying the force, the lower strain gauge is compressed and the upper strain gauge is also stretched. So in both the cases, the resistance R is changing, which can be causing a large variation in the deflection. So that's why the half bridge is used. Sometimes the full bridge circuit is also used. So in this case, in few application where the complementary pair of strain gauges is to be bonded to the test specimen is called full bridge circuit. So it may be an advantageous to make over all four element of the bridge as active for a greater sensitivity. So if you want to increase the grid sensitivity, you can use the full, but it has also some of the limitations that the electrical, that is the balancing of the circuit is required, and it will requiring the additional electrical circuitry. So this is the Wheatstone mathematical bridge balancing, and this type of the example you have already gone through, how the input voltage is supposed to be a 5 voltage, and how the output voltage will be a 0 if all the resistance are supposed to be balanced, and if there is a small change in any of the ratio of the arm, there is a large change in the voltage. So it can be used in the cantilever. So in this way, the strain gauge can be used, and this is just an overview of the strain gauge, how it is, what is the principle, how the strain gauge is used for the manufacturing of some of the sensors, for measurement of a pressure, for measurement of a load. Now it depends upon application to applications how to paste the strain gauge over the base, and which type of the strain gauge is to be used. So there are many advantages, and the limitations are there with some kind of the strain gauge over each other. So which can be selected. So these are the which are the references of the three books which we have taken while preparing this presentation. So thank you very much for your attention.